Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. A very good day to our respected lecturer and everyone watching this recording. We are from Group 50 and today we are excited to present to our project um, application of derivative in Bioscience in Malaysia. Before we begin, we would like to introduce ourselves and the member of group. My name is SITI BALQIS binti ZAIDI, number matri F258-1587.
My name is SHAZZA ZULAIKHA binti ABDUL MOHAIMIN. My metric number is F25A1624.
My name is AHMAD FARIS. Metric number is F25A 1460.
We will start presentation with SHAZZA.
Okay, I will start my presentation. Today I will present my website project titled AgroMath, Dynamic Derivatives in Malaysian Oil Palm Yield Optimization. First, I will explain the summary of the chosen bioscience problem. The bioscience problem I choose is the challenge of predicting and optimizing oil palm yield throughout its plantation's life cycle. In Malaysia, oil palm trees do not produce the same amount of yield every year. During the first few years after planting, productivity is still low because the palms are immature. Then the yield increase rapidly, reaches its maximum production between approximately 12 to 80 years and eventually declines as the trees become older. This creates challenges for plantation management because decisions regarding fertilization, harvesting, labor, and replanting depend heavily on understanding these yield changes. Next, I will explain about the importance of studying this bioscience problem. Studying this problem is important because oil palm is one of Malaysia's major agriculture industries and contributes significantly to the country's economy. By understanding how yield changes over time, plantation managers can make better decisions regarding fertilizer application, workforce planning, and replanting schedules. This helps increase productivity, reduce unnecessary costs, and improve sustainability. And in addition, our project demonstrates how calculus, specifically derivatives, can be applied in real life bioscience and agriculture situation. Okay, now I will explain the main points shown on the website. This section explains the biological growth pattern of oil palm trees over 25 years. It describes how yields start low. This is low. During the immature stage, increase as the palm matures, reaches at its peak, and then decreases as the trees age. This section introduces the real-world problem that plantation managers face. Next, I'll click on the biomathematical model. This is it. This section presents the mathematical function used to represent annual oil palm. The cubic equation models how yield changes according to palm age. Below it, we can also see the derivative equation. The derivative measures the instantaneous rate of change of yield and showing whether the productivity is increasing or decreasing at a specific age. When you look at this point, Ft equals to negative 0.024 t power of 2 plus 0.36 t plus 1.2. This derivative function tells us how fast the oil palm yield is increasing or decreasing at any specific year of the plantation life cycle. So we move to the next one. I will click the graph. Okay, this graph visually displays the yield curve by different points on the graph, and we can observe how yield change throughout the plantation life cycle. The graph helps users understand relationship between palm age and productivity more clearly. Okay, next, this is the life changing and rate evaluator. The function here is interactive feature calculates the current yield and derivative value at a selected palm age. For example, at year 10, where is year 10? At year 10, um, the website show both the and the rate at which yield is changing. This allows user to interpret plantation performance more effectively. Okay, theoretical, where is identify this section identifies the age where the derivative equals 0, indicates the maximum yield point where productivity stops increasing and begins to decline. Information is useful when planning future plantation management and replanting strategies. Okay, finally, I will explain about this. The agrotech undergraduate self-test. This section provides a practice question that allows users calculate the yield and derivative values at a specific year and compare their answers with the website solution. This makes the learning process and more interactive and also educational. Lastly, I would like to recommend one way to improve this HTML website, which is a major improvement would be enhancing the visual interface. The current website is useful information, but if we add a brighter colors to this website, it will be more attractive layout that can make it more engaging during presentation. A modern responsive design will also improve user experience and also help viewers understand the content more effectively. In conclusion, this project successfully combines bioscience and calculus to model oil palm productivity. It demonstrates how mathematical derivatives can be applied in agriculture to support better decision making and sustainable plantation management. That's all from me. Thank you.
Thank you, ZAZZA, and we will continue with FARIS.
Good evening, everyone. Today I will present my project entitled Broiler Chicken Growth Rate Analysis. The purpose of this project is to use mathematics, specifically derivative, to analyze the growth pattern of broiler chickens and identify the periods of maximum growth performance. This analysis is important because poultry farmers need more than just body weight measurement. They also need to know how fast the chicken are growing at different ages. So, as shown in the dashboard, the main problem is that monitoring body weight alone is insufficient for efficient poultry management. Farmer needs to know or identify the critical growth phase, which is the period when chickens gain weight most rapidly. Knowing this period helps farmer to optimize the feeding schedule, nutrient supply, and overall farm management. So to understand the broiler growth, we use a logistic growth function. So in this function, X represent the age of the chicken in days, and the function represent the body weight in kilogram. So the maximum predicted weight is approximately 3.2 kilograms. So to determine how fast the chicken grow, I calculated the derivative. So using the function, the derivative represent the instantaneous growth rate measured in kilogram per day. Uh, so logistic growth model are widely used to describe broiler growth because they accurately represent biological growth pattern that start slowly, increase rapidly, and eventually level off. So in this graph, it shows the relationship between age and body weight from day 1 to day 42. So at the beginning, the curve rises slowly because young chickens are still developing. Between approximately day 15 and day 30, the curve becomes steeper, indicating rapid growth. And after day 30, the curve gradually level off as the chicken approach their mature body weight. This S-shaped pattern is known as logistic growth curve, which is commonly observed in broiler production. So based on the analysis shown in the graph, peak growth occur around day 15. So the maximum growth rate is approximately 96 gram per day. This means that day 25 is the most critical stage for broiler development because the chicken are converting feed into body mass at the highest rate. So in the graph also allow us to select any day on the graph. For each selected day, the system displays the estimated body weight, the growth rate in grams per day, and a biological interpretation of the growth stage. If the growth rate is high, the chicken is classified as being in the rapid growth phase. If the growth rate decreases, the chicken enters the maturation phase where growth begin to plateau. The derivative tell us the slope of the growth curve. A larger derivative means faster weight gain, and the highest derivative value indicates the day of maximum biological performance. This information helps farmers determine when chicken require the greatest nutritional support and management attention. So, in conclusion, this project demonstrate how mathematics can be applied to solve real-world problem in bioscience and agriculture. Using a logistic growth model and its derivative, we successfully identified the critical growth phase of broiler chickens, which occur around day 25. This information can help farmer to improve feed management, increase efficiency, and maximize productivity. So that's all from me. Thank you.
Title is Concludes Rice Growth Dynamic of MR219 Malaysia Indicate Rice. The bioscience problem in this determine the optimum time for fertilizer application in MR219 rice cultivation. Farmers need to know when the rice plant grown at its maximum that to improve yield and reduce mistake. The important rice because it is major food crop in Malaysia. Understanding the ground that help farmer increase productivity, reduce cost, and support food security. And we can see the graph At day zero, the rise rate has just culminated. Growth is still slow because the plant is focused on root development. And continue with day 20. At this stage, the rice place enter the vegetative growth phase. The growth rate begins to increase. And we click to 40 day. 40 day, this is most important point. The derivative this is maximum value, meaning the rice place is growing at, at its faster rate. This is the best time for nitrogen fertilizer application. And the day 18 to 100, we can see the growth rate decrease as the rice plants approach maturity and grade formation. And we can see height represent the height of the rice plant over time, and then the directive um, represent the growth rate of the rice plants in centimeter per day. We equate the height of the MR219 rice plant over time. The graph follows hair-shaped curve. The growth is slow at the beginning, increases rapidly during the vegetative stage, and slow down again as the plant approaches its maximum height of about 7-8 cm. The directive represents growth rate of the rice plant in centimeters per day. It shows how fast the plant is growing in particular time. The maximum growth rate occurs around 14 days, which is the most important step for fertilizer application. After that, the growth rate decreases as the plants approach maturity. And then lastly, one way to approve the HTML is by adding real-time agriculture data and weather information so that user can compare the model with actual farm condition. All the website could include an animation showing the growth stage of MR219 rice to make the learning experience more interactive. That's all for me.